So here we are going to complete our design. So in the first video we have make our connection to this GSM and this LDO controller and LoRa, and here in this video we are going to make our complete routing for this PCB. So let's start. So I'm going to start with this third layer, and then we'll make our connection. So first what we can do is we have to work for power lines. So for power lines we can see our 5 volt is here, so I'm gonna place this wire over here and make this junction stronger. So for 5 volt line, it is zone priority level is 6. Zone priority is 6. So 5 volt and zone priority is 6, and this will be 5 volt, and then we'll power this area. Click on it, press D, bring it down, and then save it. We can also highlight this connection. Press Ctrl on your keyboard and then left click on it, just like. Now this net is not highlighted, so if I will click here, right, and control and then left click, I can highlight this net, and if I'll click again, so net is completely highlighted. So we'll press X and then we'll press edit, and then I'll make it 50. And I'll use this line, this layer, to make the connection. And now what I can see is it is going here, or click here, and then another net is here, so press X and make connection, and there is another net. So I'll just switch to layer and then press X and then V to place wire, and I'll again power it. Zone priority is 6, and then top layer I'll make the complete pour for this layer. Now it is done, and then double click on it and then press OK. And now I'm going to again place wire to make this junction stronger. Now again I'll click it. If I will double click on it, and I will also click on this layer because I am making this, I'm also using this layer for 5 volt, and a place I will click on it, then I can see I have poured this 5 volt to this 2 layer. Same I'll do for this top, and then I can see it is now connected to both layer, and then same for this 5 volt, and then I'll do the same for this 5 volt. Okay, now it is done, and now I'll again save it, click it, and then press X. And then edit, then 50, and now this 5 volt net is connected. Now what we can do is we have to also route this connection. So this is ground, and I'll edit and then press 8 mil, and then I can see and then V for wire, and then I'll make this connection, cancel it, but rather I'll try to keep this wire inside this controller. So I will just click here and then V. Okay, I'll change the grade to 5 mil because I'm getting a little bit of trouble in placing this wire. So okay, and now for this line, X for routing and V on your keyboard to place wire. And then X and V. X and V, Now here X and V, so this will be X and V, and this is again X and V, X and V. Now it is done, and now I'll save it, and then I'll switch to this layer, and I'll complete this connection. Same I'll do for this line. It is going here, so is this connection here, and for this line press T on my keyboard, and then I'll press here, and then I can see this is going to this net and this is going to this net. So I have to make some space, so what I will do, I will just D and then via D for more space, make this connection, okay, and I will do the same for this net, and making more space to complete this routing, and now it is completed. Okay, there is this DTR and DTR is coming here. Okay, so X and V, and then I'll make this connection. Control and click. It is coming here, so I have to route from this area. So D to create more space. Save it, and now we will complete this connection. So X and V, X and V, and then save it. Now this is done, and now what we can do is um, save it. Then I will route this connection, so it is going here. I'm going to shift this wire little inwards to create more space. This connection I'm just adjusting this 5 volt by pressing D on my keyboard, and then press X, and then I'll make this connection and I'll save it, and then I will connect this remaining connection. So this is 3 volt, and this wire, and then I'll simply keep place wire here, and then X and V, X and V, and then X and V. Okay, now save it. This is coming here, V, make connection, I'll bring it from downside, and then I'll make this connection. What left is this is 10, and now this one. Okay, V, and then connection. Okay, so now I have to connect this to the SIM card, and now let's move here, and this will come here, and now this one is going to the C7. Alright, so for C7 connection, X, then V, and then because this is TVS diode, and when the signal will come from module to TVS diode, and then other side of the TVS will be connected to this SIM card connector. So that's why I put 2 wire here, and so that otherwise thermostat will not work efficiently in that case if I will mix this connection. So it has to be in input and then output connection, just like this. And then what left is press V and then X to make connection, and now it is done. Now I can see the GSM connection is done, only I can see the ground is floating and for the spark is left. And now this reset is not showing any connection here, so I have to again move to the schematic and then the reset is pin 7. Okay, so it is after register R40. Okay, it is after R40. Okay, now it is showing connection. Sure. Save it and then okay, save it again. This is Mossy pen. Okay, so it is making connection here. So press D on your keyboard and then make your connection. Now again I can see this is the ground and this is a reset. Reset pin is now connected and now I'll complete other connection. This one and this one. Now what we can see is what connection is left here is this one. So I'm gonna make this junction stronger and then edit 50 mil. or instead this one. This is VDC 7. VDC 7. I only need this area. So, and same for here. VDC and 7. This is 3 volt and this one is 3 volt. So edit 20 mil and then this is 5 volt and this is 5 volt. Save it. And now what we can do is we can see this and this net are same, and it is the power pin of the controller. So we are going to, so what we'll do is, this is C63 pad 2. Okay, so I'll select this line and 63 pad 2, and I'll consider this as 8. Let's consider this as 9. C63 pad 2. Okay, and solid. So it will act like a plane for this controller, and I'm going to switch to this second layer and press OK, save it. Now this is the area that I want to keep out. I'll use this keep out copper fill. Okay, and then area name SIM card. So this area will be keep out. Okay, and also for this UFL connector, all area, and this is for antenna GSM. Okay, keep out, and then this will be for LoRa antenna. Okay, I'm gonna save it, and then view, grid properties, view unit to millimeter, and then grid to 1 mm, and then S place. Okay, this will be our center. This is 0, 1, 2, 3. One, two, three, 1, 2, 3. Okay, and then again I'll place S here. This is 1, 2, 3. Okay, this is logged. Okay, this is logged and this is logged. Same again, place S and then this will be 1 2 and 3, 1 2 3. Okay, now logged it and then again click here and then S, press S on your keyboard and then center, and then we can see this is again 3, 1 2 3. Okay, and now logged it. And now what we can do is let's try to keep analog and digital ground separate. So I'll just plan by drawing this user drawing. So add it and then make it 30 mil, add it, I forgot to change the unit, so this is a line, so take a line and then add it and then 30 mil. So again 30, and then again 30, add it, 30 mil again, add it, 30 mil, add it, and then again 30 mil. So what I'm trying to show is I'll just this area is totally the analog ground, so we are going to separate analog and digital ground. So how I am going to do is let's say I'll just click here and then select this copper core and I'll change my grid to, let's say I'll select this 20 mil and then I'll select ground, this is ground, and then I'll click all this layer and this will be ground, and priority label I'll keep 0 for the ground, and solid, okay, clearance 10 mil, and then remove Iceland always, okay, looks okay to me. And now this will help me to plan connection. Sometimes we have to switch to this powering adjustment from by pressing shift and space bar if something will create problem while doing powering on a board. So escape and then double click again. Ground priority level 0, solid clearance minimum with OK, solid fill always, and then okay. So the keep in the keyboard layer now there is no copper. In the keyboard there is no copper, as we can see. And now we're gonna save it, and then we'll do the same for upper area. So this will be ground, now here ground 0, clearance minimum with pad connection, all looks okay. Save it. Now the upper area is power, right? The upper area is power, so it's ground. We shouldn't mix the entire ground of the power to our digital connection. So what we can do is, this area we can see this is for GSM, right? And this is the output area. So we can do one thing. We'll just press D on my keyboard, and then I will just adjust the track, and then I will report again, and now save it, and then I'll click here, and I'll just connect this ground from here. Double click, this is ground connection, ground 0, okay. Now this ground area is connected, and I'll do same for this microcontroller area. So this is ground 0, solid, okay. This will be ground. I'm gonna save it, and then first I will check the DRC connection. I'll check design rule check, and then I'll run my DRC to check the violation. And now first I will check if there is missing connection. So these are our clearance. Okay. Okay. So these are the unconnected item. Okay, so click here, and it has to be connected with this connection. So we are gonna connect this first. Okay. Okay. Report, and then edit. Okay. What is the other violation? Missing reset. Double click and then report all. Now it is done. Now save it, and now we can also for this fill area for this ground 0, ground 0. Okay, save it. And now we have to do wire stitching. So, and again we have to also correct this we have to match this 50 ohm impedance to this antenna. So first we'll do wire stitching. We'll make wire stitching with the ground connection. So we are gonna first disable this zone area, and then I'll stitch wire. So edit, and this will be ground. Okay, I'll first wire stitch. I will first stitch wire to the edge of our board. It is for the EMI protection from the external world. So having a wire stitching near the edge of the PCB will protect our PCB from the external EMI. We're going to do this wire stitching over here. So just copy it and then after completing the design we have to do wire stitching. It will make our ground connection more stronger, and it will also help to keep EMI away. So I have stitched the wires to the ground, and now when I will run the design rule check, I can see warning, error, and this unconnected net again. So when I click, I cannot see it clearly. So what I will do is, which is here, I can see it, but if I'll do it dim or even hide it, I'll see it more clearly. So in the layer we have option to dim the layers. So now I can delete it and then run again to inspect design rule check. and then run DRC. Now there is no unconnected items, so that means entire nets are connected. So let's see violation. It says there is a clearance issue. It says 7.87 mil is the connection, but it is clearance is 8 mil set, but it is actually 7.87. Why it is giving is because our footprint gap, our footprint pin to pin pitch is clearing problem. So we'll go here to the rule setting and then minimum clearance we can set it for 7 mil and then okay, and if I'll go again I can see it is 40 50 and net class the clearance default clearance is set as 8 mil. Okay, so the all layers should be will have a gap, will have a clearance of the 8 mil, and in the minimum setting we have set to 7 mil. So now let's see, design will check and then run DRC. It is again not clear, it is again asking for 7.87. So again we'll go here and then to default setting. It was set default to 7.87. Now it has 11 error. Save it and also save this one, and I will open this design rule checker again. It says the footprint has malformed courtyard. It is happening because of this one. So what I'm going to do is I will exclude this violation and again inspect, design rule check, exclude. It says the courtyard is overlapped. I click here. The courtyard of this footprint might have overlapped. So I'll go to the normal view, and if I will disable this zone, so it is because of the courtyard of the footprint. The footprint has courtyard layer that we add to keep clearance between the two components. So we are going to exclude this violation, and this is the courtyard that says it's overlapped. So we're gonna move this here and exclude this, and malform courtyard again exclude. So this is the complete courtyard. Save it and then run DRC again. Exclude. Now we are gonna enable this zone and then we will refill again. Okay, now save it and same we'll do here and then save it and then inspect design rule check, run DRC. There is one error again, exclude this. Now it says there are warning. So for warning we can also go here to this rule setting and violation. Why is not connected or connected warning. Okay, this is okay. Let's go to the warning sign and see this is for schematic parity warning, missing footprint warning. Okay, so these are the warning signs. So that warning notification is coming for this message: duplicate footprint, missing footprint, extra footprint, pad net doesn't match a schematic. Okay, so let's check again, inspect design rule check, and track has unconnected end. It says it has unconnected end. When I check here, it is already connected. So I'll disable this. I cannot see any issue with the connection, so it is connected or connected on one layer. Okay, so I'm gonna delete this and then it says it has unconnected end for this entire track. why it is saying this. So when I go to the object and disable this arrow is showing a warning. So it is, let's say this is for DTR. Okay, so inspect, design rule check, track as unconnected end. So when I click here, okay, this net is already connected between this point to this point. It is already connected, but it still says it has unconnected end, unconnected end, unconnected end, which I cannot see any issue with it. So track as unconnected end, silk is in clip by solder mask. Okay, so we're gonna ignore this. And this layer. Okay, now tool, inspect, design rule check again. If I click here, this track is already connected, so I don't need to worry about it. So unconnected end. So what I'm going to do is I'll just go to this board setup and I'll check the warning sign. Track has unconnected end. Unconnected end. A track is already connected. It has no unconnected end. Why it is showing error? I have no idea. So I'm going to ignore this for now. And then tool, inspect, design rule check, and then run DRC. Now it says the silk screen is clipped by solder mask. So again I'll go to the rule setting and look for warning, silk screen clip by solder mask, ignore, silk screen overlap, ignore. Okay, then tool, inspect, design rule check, run DRC. Exclude, drill holes co-located. And then run JSC. Exclude. Okay, that means there is no error. So this is again the malform courtyard. We can also disable this from here. So we'll go to here to violation and check for the courtyard. No courtyard, malform courtyard, ignore. Okay, now tool, inspect, design rule checker, run DRC. No, there is no error. Save it. And now we'll report this entire connection. Okay, and now we'll go to view and 3D. So the wire stitching that I have done is already tinted. So when I will generate curve, so it will comes with the tinted wire. So while generating curve, it has also an option to untint or tint. So I'll prefer to select tinted wire while doing wire stitching on my board. So it will not allow us to see those wire, means we cannot it will not visible to us because the device size is small and it is already tinted. That means masking is done and the holes is not totally visible. So we'll see the clean board. When we, after fabrication, we will see the clean board, clean PCB. Tiny small holes will be seen, but it is not clearly visible. So, and this is how we do our PCB design. But there is also one thing left about this track weight, right? So when I'll go to the board setup, I can see first the antenna is routed on top layer. So top layer has dielectric of 18.89. When I will view unit to millimeter and then again, so it is 0.48 mm. 0.48 mm is dielectric for this prepay, and it is 4.2, right? So there is a free tool available, Saturn PCB calculator. You can use this one. So we have to go to this conductor impedance and then select this coplanar wave. Select this to 4.2 because our dielectric in our layer stack up is 4.2. And now what we have to do, so this is the dielectric, so we'll change into metric and this will be 0.48. and now again ampere. So this is the dielectric, right? And we need 50 ohm impedance. So if the track weight is 10 mil and the gap is 8, how much impedance will get? 78. Okay, so we'll get 78 impedance. So we have to get lower impedance. To get a lower impedance, if we'll increase the track weight to 15 mil, 17, okay, I'm gonna keep this 8 and then 20 and then 24. So by keeping this 24 mil width, and because of this conductor height and this gap, we'll get this 54 ohm impedance. So it has this Saturn PCB calculator has a little bit of tolerance, so we can take this as a 54 mil using by keeping our track with 24 mil. So let's do it. 24, gap is okay, 8 mil, 4.2, okay. So 24 mil. So we'll select this, we'll go here, and again I'll change unit to mil, and then I'll select this 24 mil once again. Okay, 24 and then 24. Okay, again for this line 24, again we will re-pour again, and now save it. Now we have to do little bit of wire stitching around antenna. So this is important because the antenna line should match 50 ohm impedance, and it should have proper wire stitching around it to prevent it from EMI. And there is again one for this LoRa model. So okay, now it is done. Now again we will re-pour again everything. So re-pour and then re-pour, save it, and then click it and then press S, and I just brought the center to here, and now it is done. And save it, then inspect, design rule check again, then run GRC. Now it is 0, including error, warning, they all are 0. So now we have completed our PCB design. So in the next video we are going to generate our fabrication file. So see you in my next video. Hope you like my video. So I'm trying to bring this entire tutorial for Kicad. If you like my video, then please like it and also subscribe to my channel. I'll also bring some new videos regarding Altium, and it will be soon after Kicad. So see you in my next video. In my next video we'll generate our fabrication file. Bye, have a nice day.